Alrighty, so this is going to be our Python coding bat review part 8. So we are approaching the final classes in our coding bat session, I guess. We're almost done with all the problems. So it's, I guess, for the next kind of classes, we're going to be moving on to a different topic, right? So if we come over here, we pull up Coding Bat, and we come here, we get to Python. Let's log in. So all the one topics are pretty easy. We have warm up 2 with some problems we haven't done. We're pretty much done with every problem with Logic 2. Actually, I'm pretty sure we did finish everyone in Logic 2. We still have, I believe, 2 in String 2 left, and a couple in List 2, right? So that's kind of the stage of where we're at. So once those problems are finished, Coding Bat for this class will be done, so an email will be sent out for that. Now, when we go ahead and finish up this kind of Coding Bat class, if you ever have any questions, then at least one of these videos will have one of the answers. And I recommend that if you have a specific question, then you go ahead and you watch one of them, right? So we're going to go ahead and jump into list 2 today. So there's a couple problems that we haven't done yet, so we can jump in here, go into sum 13. So sum 13, so remember we need to take those 3 steps to make sure we program this correctly. So I'll give you guys about 2 to 3 minutes to read out the instructions and form your own pseudocode. And once you have done that, we can move on from there. You're able to form some sort of basic pseudocode for this. So we are given define sum 13, sum 13 and nums, I believe. So when we go ahead and we do this ourselves, we got to think about, how exactly is this going to work, right? So when we read over this problem, we get, alright, return the sum of the numbers in the array, returning 0 for an empty one, except for the number 13. Because 13 is unlucky, so it does not count, and numbers that come immediately after 13 also don't count. So what exactly does this mean? Well, we look at this, and there's a couple of rules we have to follow. So first of all, the goal of this method is to find the sum, right? But there's an exception in this case, the number 13. Now what's so special about 13? Well, first of all, 13 cannot be included within the sum, right? So if 13 is the sum, if 13 is one of the numbers to be included in the sum, then we ignore 13. And then it says numbers that come immediately after, which means that it includes the number right after 13, right? So if we were given an arrangement, say 1, 13, 2, 5, right, the 13 and 2 would be ignored. So that would have looked like 1, 13, 2, and 5. And all we need to do here is add 1 plus 5, which equals to 6. So what exactly is the pseudocode for this? Well, this is a sum. And when it's a sum, this means that we need to go through all of the variables in here, right? So, or not the variables, the values in this list. So there's two ways to go about this, again, as there is for every single way of kind of solving these problems. And we can go over both ways, and it's important to make sure that you understand both ways. So the first way is going to be your most simple way. We're going to loop through all of the numbers. Alright, and once we loop through all the numbers, we need to check, is the number 13? If it is the number 13, then we need to have a second check. Is it the last number? Now, why do I need to check whether or not it's the last number? That doesn't seem to matter because I'm ignoring 13 regardless, right? But what it does matter is the fact that we are supposed to ignore the number that comes immediately after 13. And when we go ahead and we have to ignore the number that comes immediately after 13, well, we can't just pull a number out of nowhere if 13 is the last number. So we still need to check if 13 is the last number. And if it is, then we can skip 13 and the next number. If it is not the last number, then we just go ahead and we skip 13. And finally, whoops, I spelled that wrong. And then finally, we have loop. When we loop through all the numbers, if the number is not 13, then we add to final sum. And after we finish this loop over here, we return the final sum. So this is going to be your regular way. This is going head on, right? You're just adding the values together. Now, list actually has a very special function. You might be wondering, well, yeah, there's obviously some basic ones like determining the location of where one of these is located on the list, but there's another special function called sum. So what sum does is, well, it sums every number up. Has no rules, it just adds everything together. So this method, this second method, is going to be called using a complementary thinking system, right? What complementary means is instead of going forward and checking all the possible cases, it takes the total number of cases and then subtracts all of the non-possible cases. So in this case, we're going to be subtracting 13 and the number before it, right? So we're going to keep track of initial sum, right? And then we need to loop through all of the numbers. And if the number is 13, then we can go ahead and remove 13, right? But we have to remember that second case comes in again, and is it the last number? So if it is the last number, then what we can go ahead and do is, instead of skipping over 13, we subtract 13 from the sum and the next number. Else, we just go ahead and we subtract 13. We have our second layer of else, and we just do nothing, right? So in this case, we can actually just go ahead and ignore that. And finally, we can go ahead and return our final sum obtained from the initial sum. So these are two very similar yet very different pseudocodes to solve this problem. This can be a little hard to get at first, so we're going to be doing both of them, and then I will explain to you why it's important to know how to do both of these. I'll give you guys approximately 4 to 5 minutes to go ahead and review over this, and then we're going to move on and turn this into actual code. So hopefully you were able to go ahead and understand what's going on in the pseudocode over here. So now we're going to be converting this pseudocode into actual code. So first thing we're going to be doing is we're going to be doing this one over here. So first thing that we do is we loop through all of the numbers. So there's two ways of doing this. We can either go ahead and loop through in the range of it, or we can go ahead and loop through the actual items. Now in this case, we can't actually go ahead and loop through it in all of the items, because we have to be able to access the index of the number, because we want to check if it's the last number or not. Now this leaves us with the only option to loop through the indexes, right? But we got to think about it. Well, is there any other way we can do this? And after thinking about it for a little bit, it's important to not skip over this step, because we want to make sure we simplify it down as much as possible, because getting the indexes is essentially another step, right? Because that means that when we want the number, instead of just calling I, we have to call it index I, which is like, might seem small, but it can often lead to a lot of misunderstandings. So when we loop through all the numbers, we do for I in range, right? Length of nums. And then when we come in here, we think, alright, well, if nums I is equal to 13, then we can get through this one. Now, we get into the second one. If I is equal to length of nums minus 1, or it's equal to the last number, right? Then we go ahead and we can skip 13 and the next number. But we think about this, we go like, well, how do we skip the next number? We can only skip at this index. Well, this is where we can simplify it a little bit. What we can go ahead and do is, if nums I is equal to 13, or nums I minus 1 is equal to 13, meaning that the number before it is in fact equal to 13. This is what it's checking, right? Then it goes ahead and will kind of, do this test. Well, what happens if this is at the 0th index? Then it'll go ahead and try and grab in the negative first index. Well, this is what we need to do. If I is not equal to 0 and that. So this kind of encompasses that entire method now. So in this case, we just go ahead and do nothing, right? Now, this seems quite inefficient. So instead what we can do is just write a not, right? We can put a not on both of these. So what this is essentially doing is it's just checking whether or not 13 is at this number index, right? Or if the number before it is equal to 13. Well, for the sake of this program that we're doing, I'm not going to be doing that, because that starts getting a little confusing. So instead, we're just going to write nothing here. And instead, we're just going to go to the else. And in the else, we are going to do sum plus or equal to nums I. Well, we need to define a sum before, right? So what we have to do is we have to define the sum ourselves. So sum is equal to 0. And in the end, we can go ahead and just return sum. So that's kind of this first program right here. So I'm going to go ahead and run this. 1, 2, 3, 4, 5. Oh. There's a blank line here. Well, I guess we could just do sum is plus or equal to 0. And as you can see, we get all the cases correct, right? So we can obviously simplify this one over here. So if not the cases over here, and then we just switch the 0 with nums I, and we delete this else over here, we still get all the cases correct, right? So I'll give you guys about 2 minutes, 3 minutes-ish to go ahead and make sure you understand what's going on here, and then we can go ahead and find out how we can go ahead and implement this second method. Okay, so 2 minutes. Now we're going to go ahead and review over the second method. So the second method is going to just define sum as sum of nums. And if you kind of want to just see what it does, oh, whoops. Final sum. There. We gotta return that. You can see that it just goes ahead and sums everything up, right? This one's a good example. 13, 14, 16, 29, 31, 32, and then 45. So it ignores the rule, obviously, which is our job to go ahead and do. But that's what sum does. It's very useful if you're just trying to go ahead and find the sum, right? So now that we've done this, well, we want to go ahead and kind of fix this sum up over here, right? And when we want to go ahead and we fix this sum up, it's we got to think about, well, we have to remove this 13, right? So just think about for a second, how exactly is this I guess working? How can we go ahead and we fix this problem? So the solution to this is obviously to remove 13 and the number right after it. So we're going to go ahead, we're going to write the same loop for I in range of length of nums. Then if I is equal, or if nums I is equal to 13, or I is not equal to 1 or 0, and nums I minus 1 is equal to 13. Then what we can go ahead and do is do final sum minus or equal to, basically the opposite of plus or equal to, nums I. And we can go ahead and return final sum. And as you see, we get all of the cases correct. So I'll give you guys another 2 minutes to think about this, and then I can go ahead and explain what exactly is happening here. Alright, well at this point you might be wondering, well, what exactly is so important about this? Well, when we go ahead and solve problems, in this case, the time it takes for this computer to get the solution is relatively similar for both of these cases over here. Right? But the thing about this is when you're doing these kinds of problems, many times the time it's going to take for your computer is going to be different is it when you use these two different methods. So it's important to figure out which method is going to be faster, right? Going from the back or coming in from the front. So that is all for the class today. I don't have anything else. If you have any questions, feel free to post them. If you don't have any questions, thank you for watching. See you guys next week. 2 weeks till winter break, so we're almost there. But yeah, if you don't have any questions, I guess we'll see you next week. Can I enlarge the font size? I don't. Is that a little better? Yeah, if font size is a problem, I can definitely go ahead and use a bigger font size next time. So yeah, I guess that wraps it up for today's class. See you guys next week. Thank you.